This video is going to illustrate how to graph a sine or cosine function. You should all be familiar now with the unit circle. The unit circle is not a graph of a function, it's just a method of knowing your sines and cosines and your other trig functions of special angles. So your 30, 45, and 60-degree angle and any multiple of those. And so this isn't a graph of a function. And so if we were to convert both our cosine and our sine into a y equals equation, what would that look like and what would the graph look like? So let's start with the y equals sine of theta. So theta is going to be our input, that's like our x, and theta is going to be our angles in radians. We're not going to be in degrees when graphing these. And then my output is going to be, what is the sine value at that particular angle. So sine of 0 is 0, sine of pi over 2 is 1, sine of pi is 0, sine of 3 pi over 2 is negative 1, and sine of 2 pi is 0. And so if I were to graph these on my xy axis, my x-axis is in my radians angles, and I know it's in decimals, but anytime you want to look at the axis, look for your 3.14 and your 6.28, that represents your pi and your 2 pi. And so I'm going to plot these points just as coordinates now. So 0, 0 is at the origin. Pi over 2 is the same thing as 1.57, and I have a y value of 1. Pi, 0. 3 pi over 2, negative 1. And 2 pi is 0. And if I were to continue this table and go around the unit circle again, my points would go in a repeating pattern. So my next point would go up to 1, and then I'd be back to 0 and back to negative 1. This is called a periodic function because it repeats itself. And so it looks like this nice smooth wave, and it goes on and on forever. So the first thing that you need to know is that anytime you're given a y equals a sine function, it's always going to start on the middle. And what I mean by middle is not like the middle like the y-axis. What I mean by the middle is horizontal. And so we have a maximum at 1, we have a minimum at negative 1, and what happens in the middle? Well, that's 0. And a sine graph always starts on that middle line. If you're given a positive sine function, it always starts on the middle and then it goes up to the right or up to the maximum. If you have a negative sine function, it's going to start on the middle, but then it's going to go down to the right. Because remember, whenever you have a negative function, it's a reflection over the x-axis. And so a negative sign would start here at 0, 0. If there were a negative sign in front of the sine of theta, it would go down to the right instead of going up to the right. And then you would just repeat the pattern. So you'd go middle, minimum, middle, maximum, middle, minimum, middle, maximum, and etc. So I'm going to show you in this video how to graph a sine and a cosine function just using 4 simple steps without having to make a table of values, and you'll be able to do this without using a calculator, and it's much quicker than using a calculator. So let's take a look at the cosine function. If I were to take what I know from the unit circle and convert it into a table, my equation is y equals cosine of theta. So now my angles in radians, I'm going to plug in to this equation, and my output is going to be what my x value is in that unit circle. So cosine of 0 is 1, cosine of pi over 2 is 0, cosine of pi is negative 1, cosine of 3 pi over 2 is 0, and cosine of 2 pi is back to 1. And so plotting this on the xy axis, instead of starting at 0, 0, my graph starts up at 0, 1, then it goes back to 0 at pi over 2, pi negative 1, 3 pi over 2, 0, and then 2 pi, 1. And then if I were to go around the unit circle again, I'd go back to the 0. And so I'm going to have a nice smooth curve when I graph these and connect the dots, and this is another periodic function because it repeats itself. A cosine is always going to either start on the maximum or the minimum, so wherever that starting point is. If you have a positive cosine, that's how you know you start on the maximum, and if you have a negative cosine, that's how you know to start on the minimum, because it's a reflection. So if this were a negative cosine, a negative symbol in front of my cosine of theta, this would have gone from 0, 1 to 0, negative 1. It would have been a reflection. So let's take a look at what a sinusoidal equation will look like. And sinusoidal can be sine or cosine. So this is an equation in standard form. and I'm going to break it down to what the four parameters stand for. So the d out front, now it could also be at the end of the equation. It's whatever you're adding and subtracting to your cosine function. The d is the middle of the graph, or the vertical shift. So usually it's at 0 if there's nothing out here being added. But if there is a number, positive or negative, that's where your middle is. That's what your vertical shift is. The A stands for amplitude. And to break that up a little further, the amplitude is the vertical stretch, or you could say it's half the distance from the minimum to the maximum. So take that full distance from min to max and cut it in half. That's what the amplitude is. If there is not a number out in front of cosine or sine, then the amplitude is going to be a 1. You can never have an amplitude of 0, then it won't be a sinusoidal function. This b that is in front of the x, this is the horizontal stretch, and we will use this number to calculate what the period of the graph is going to be. So down here, the period is the distance it takes the graph to repeat. So the two examples that I had before, it was from 0 to 2 pi, and then my graph would have kept repeating itself, so the period of cosine and sine is 2 pi. If there isn't a b in front of your x, then that period is going to be 2 pi. So it doesn't change. It's always that's gonna be the standard, is that it's gonna be 2 pi unless there's a number in front of x. And then the last parameter that we have to worry about is this c value, this x plus or minus c. This is called the phase shift, and this is where we shift the graph left or right. And that's also how we determine where the graph starts. One thing I forgot is about the amplitude. Your amplitude is always a positive number. So whatever is in front of it, whether it's a plus or a minus, your amplitude should always be positive. The minus just tells you where to start your graph, because amplitude is describing a distance, and you can never have a negative distance. So always remember when you list your amplitude out, it should be a positive value. So there are 4 simple steps when you are graphing a sine or a cosine equation, and you will be able to do this without a calculator and without making a table of values. The first thing before your 4 steps is that you always want to make sure your equation is in standard form. And the equations that you guys have on your notes, those are already in standard form. The b is in front of the x, and it's in front of a set of parentheses. If it's not in standard form, you need to make sure you factor the b out. And I'll show you an example of that in example 1. Okay, so I have maps spelled out alongside my paper. These are the 4 steps that you are going to take in graphing a sinusoidal function. So the first one is m, the middle of the graph. That's what that d value is. The second step is knowing your amplitude, and that will be the number in front of your cosine or sine equation. And this is going to help us determine the maximum or the minimum of the graph. And the minimum will be at the middle minus the amplitude. And these steps will all make sense as I walk you through the examples. The P stands for the period, and now this is not given in the graph. We have to use something, or it's not given in the equation. We have to use something from the equation in order to determine the period. And so we are going to use the equation 2 pi divided by b. So b was that number in front of x, that's our stretch factor. We will determine the period from that number, always using 2 pi divided by b. And then once we have the period, we have to label our x-axis by the x-axis increments will always be the period divided by 4. So if the period is pi, our x-axis increments will go by pi over 4. If the period is 3, then the x-axis increments will be 3 over 4, or 3/4. And then the last step to graphing will be determining your phase shift. And this also will determine where the graph starts. If you have an x plus c, you will shift the graph left. If you have a x minus c, you will shift the graph to the right. It's a little backwards thinking, but it's because it's x minus, and if you subtract a negative, it turns into a plus. And so x plus c is to the left, x minus c is to the right. So let's walk through the first example. It says, use maps to graph 2 periods of the following function. Y equals -3 plus 2 sine of pi x minus pi. Now, this is not in standard form. That's the first thing you need to look for before you walk through the steps of maps. So I need to factor this pi out. Now factoring does not mean just eliminating it and getting rid of it. It means to divide each part of what's in the parentheses by pi. And so when I do that, I'm going to be left with just an x, and then pi divided by pi will be 1. And so this new equation is in standard form. So walking through maps, the first thing is to look at where your d value is, and that's our middle. And so that's out front, and we have a middle at -3. So I'm going to graph a dashed line at -3, and then I'm going to label it and say that that's my middle. The next thing is to look for your amplitude. The amplitude is the number that's immediately in front of sine or cosine, and in this case it's an amplitude of 2. And so now I'm going to use that to calculate my maximum and my minimum. So my maximum is -3 plus 2, and that'll be -1, and then my minimum is going to occur at -3 minus 2, and that's at -5. So I'm going to, once again, draw in dashed lines at these points, and this is going to tell me that my graph is never going to go above my maximum or below my minimum. And so it's always going to be bouncing or oscillating back and forth between these lines. The next thing is calculating the period. Now the period is not given in the equation, but there is something in the equation that helps us determine what the period is. And in this case, it's that b value. And so I have to look in my equation. My b value is pi. That's not going to tell me the period, but that's going to help me calculate it. And so the period is always 2 pi divided by that b value, or in this case 2 pi divided by pi, which equals 2. So the period of the graph is going to be 2 radians instead of 2 pi radians. And so it's much shorter than it is before, because 2 pi is 6.28, and in this case it's going to be a 2, so it's almost cut into thirds. So then the next thing is, how am I going to label my x-axis? Well, now my graph is already labeled for me, but with your graph paper it won't be labeled for you. So I take the period and I divide it by 4, and so my x-axis is going to be labeled by 1/2 or 0.5. So 0.5, 1, 1.52, and I'm going to go once in the positive direction and once in the negative direction. And then the last thing is the phase shift, and this is going to be 1 to the right because it's x minus 1. And so I'm going to take my starting point, which would normally be on the y-axis, and I'm going to shift it to the right one. But the next thing that you have to determine is, what type of graph is this? Well, it's a sine graph. Sine always starts on the middle line, so I'm going to be on the middle, and I'm going to have a phase shift of 1 to the right. And so here is my first point. Now that's my starting point. And so then I have to look at, well, is this a positive or a negative sine graph? Well, the number in front of the 2, or the sign in front of the 2, is a plus sign, so that means it's positive. That means from my starting point, I am going to go up to the right, and I'm going to plot a point there. Then I'm going to go back down to the middle, and then I'd go back to the minimum, and you repeat the pattern: minimum, middle, maximum, middle, minimum, middle, etc. Well, since I'm going off my paper, I'm going to go backwards. From my starting point, instead of going up, I'm going to go down to the left. Come on. Then I'm going to go back up to the middle. Then I'm going to go back up to the max, back to the middle, to the minimum, and then back to the middle. And when I put it all together, it will look like this. And so there's a nice sinusoidal function. And then another thing is that we will be asking you guys to find the domain and range of these functions. Well, the domain is, what are your inputs? Well, or how far left and how far right does your graph go? It's going to the left forever, it's going to the right forever. So that means my domain is all real numbers, or you can think of it as x equals, and then it's this fancy r with a double bar. And then your range is all the y values. So how low does the graph go and how high does the graph go? So with this example, my range is -5 is less than or equal to y is less than or equal to -1. Its lowest point is -5, its highest point is -1, and that would be the range. This next example I want you to try on your own or with a partner. Actually just walk through the steps of maps, pause the video, and then come back and check your work. So the maps of example 2, you'll notice that my equation is in standard form, so I don't have to worry about factoring out my b value. The middle is at 1. Now it's not out in front. In this case, it's out at the back. It's whatever you're adding or subtracting to your cosine function. So I'm going to graph a dashed line at 1, and I'm also going to label it. And then I'm going to go to my amplitude. That's going to tell me how high my graph goes and how low. So then my maximum will be my middle plus my amplitude. So 1 plus 3 is 4. And then I'm going to sketch a dashed line there. And then my minimum is going to be my middle minus my amplitude. And so 1 minus 3 in this case will be -2. And then I'm going to draw a dashed line there as well. The next step is the p. P is not in the equation, but we use the b value for it. And in this case, the period is going to be 2 pi divided by 2. And then from there, I need to figure out my x-axis increment, so pi divided by 4. So here's pi over 4, 2 pi over 4, which is pi over 2, 3 pi over 4, and 4 pi over 4, which is pi. And then my shift is going to be that value that is in the parentheses with the x plus pi over 4. That means I have a shift of pi over 4 to the left. And my starting point then, because this is a cosine, I have to look at whether it's a positive or negative. And because the sign in front of the 3 is negative, that means I start on the minimum. So my minimum is at -2, and then I have to remember I have a shift of pi over 4 to the left. So my starting point is just going to be at -pi over 4, -2. And then there's no place to go from there except up to the middle. So I have to go to the middle in both directions. And then from there I go up to the maximum, back to the middle, to the minimum, back to the middle. And then going in the other direction, I had to go back up to the max, and then it's back to the middle. And when you put it all together, you have nice sinusoidal function, nice smooth curves. The domain, once again, is going to be all real numbers, and then your range is going to be from -2 to 4. So this video covered graphing sine and cosine equations. Your next step will be some group work on these. Have a good day.